Excuse me. Sorry.
She's in there like.
Just waiting on Daniel now.
All right.
There he is.
There we go.
Hello?
Hello.
Hi.
Hi.
Okay. I'm just trying to open the quiz. I think we need that applet thing too.
The what?
The applet that you do the Z-scores and stuff on.
Oh. I read the preparation for that quiz, so I don't.
Okay. This is where it gets hard for me, but we'll try it.
Okay. 1 second, let me pull up the lesson.
This one, 18 questions.
Okay, let's do this.
You guys have it open?
Yes.
I do now.
Oh, okay.
Okay. Do you want me to read question 3?
Yeah.
Okay. The total area under a normal distribution curve must equal
1.
1. Okay, that's what I thought.
Yeah, that's one of the basic properties of the density curve, which is the distribution curve or whatever you want to call it.
Okay.
Awesome.
And then number 4 says, you have it, Daniel?
Yeah.
Okay. Under certain circumstances, a normal distribution curve can drop below the x-axis. And I said false. And in my notes, it says the density curve always lies on or above the horizontal axis.
Okay.
Yeah. I agree. Looking by all the graphs, it doesn't look like that. Otherwise.
Right. Question 5. A normal distribution curve is symmetric.
Yes. Symmetric means that if you
They are symmetric if they're considered
it
normal.
looks pretty much the same.
If they're not normal, then that's when they have like the skewed to the left or skewed to the right.
Oh, okay.
Yes.
Use the following triangle to answer the next 2 questions. Which of the following elements of the figure represents the z-score? I would say,
B.
well, because if you look at the applet, here, I'll share my screen with you guys.
Okay.
Okay. Can you guys see my screen?
I can see, yes, now I can.
So if you look at the applet, when you look at which is the same image as on their little homework quiz,
Yeah.
the C is where you would see the z-score.
But what is it referring on B?
B
I
is
think-
just the left-hand portion of the
Yeah. That's
data.
what I was thinking, because it's just a number.
Yeah.
And
But doesn't it show the z-score on the by the line by the A on the so is it in between those 2 lines? Does that make sense at all?
Well, I'm not sure if it's asking like, I'm not sure if it's asking if this actual square where C is at is the z-score.
Oh, okay, I see what you're saying. Yeah,
Because on my applet, that would be the z-score.
right.
Do you see what I'm saying?
Yeah, I do.
So I would say it's C. Because if you were using that computer program, that's what it would be.
Oh, okay, so C.
Yeah, because it's saying which of the following elements. Well, to me, that would be the
Yeah,
square.
makes sense. So -1 and 1 would be the z-scores?
Yeah, so I guess that's where I'm confused because it shows the z-score next to both numbers on the applet.
I know.
So I'm like, oh, is it none of them?
Well,
Well, I think, is there more than one z-score?
it depends on which side, which portion of the graph you're looking at.
Yeah, that's true.
I'm not sure. But I'm putting in C for that one. I'll unshare my screen now. Which of the following elements of the figure represents the probability of the z-score will be greater than 1?
Greater than 1?
I would say A.
Yeah, because you have more on the numerator dividing.
Right.
The number will be greater.
Hold on, I'm gonna look.
Yeah, because the total sample minus the mean, I mean the sample you're evaluating minus the mean divided by variation.
I don't think it's any of them.
Why?
Because like if you highlight that A and if you're in the applet and you highlight those two portions, the z-score is still 1. I would say none of these represents the probability that the z-score would be greater than 1.
Okay, that I don't know. Okay, so we answer none of them for now.
Yeah.
My guess would be A, but for now.
Okay. According to the 68, 95, 99.7 rule, what percentage of the data from a bell-shaped distribution will be within 1 standard deviation of the mean? I have that in my notes. It's 68%. So it would be 0.68. Oh no, it'd be 68. Sorry, it says write your answer as a percentage such as 42. Suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal.
Suppose this is from a standard normal distribution. It
would be 0.6827.
Where are you getting these numbers from?
So you have to open up that normal probability applet. And you would highlight that portion in between -1 and 1.
Oh, I see now.
And
So-
the area up at the top
Uh-huh,
is the proportion.
yeah. And okay,
I
so we
think-
answered 0.6. 0.6827 or 0.63.
But we would have to
0.683.
round, so
Yeah.
it'd be 0.683.
I'll read the question 10. It says, suppose that the z-scores come from standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -2 and 2? -2 and 2. All of it? 1? Or maybe, wait.
It'd be 0.955.
Oh, you can drag those red lines. I see now.
Yeah.
Perfect. Or you can actually type.
That is point what?
It's 0.955.
0.95. Thank you.
Wait. For mine, it says mine's 2.
Huh?
Wait. Oh, there you go. I was highlighting something else.
Oh, okay. It says, suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -3 and 3? So wouldn't it be 9? It's that 9.
9973.
Yeah, so we would put,
0.997.
yeah. So this is where that rule for the bell-shaped distribution or the empirical rule is coming in. Look carefully at your answers for the last 3 questions. What do you observe? The values match the 68, 95, 97 rule,
Yes.
or 99.7. Use the following information to answer the next 6 questions. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is 0.65 grams. P times kg -1 times D -1. And the population standard deviation is 0.07 grams. P times kg -1 times D -1.
Yeah, that refers to grams of protein over kilograms in density. Now, what's D?
What population or what proportion of the population have a protein requirement that is less than 0.6? I have no idea how to do this.
Yeah.
Okay, so what we're given the standard deviation,
Which is,
0.07,
okay.
and
This is that part where it's saying you solve it.
the population mean protein requirement for adults is 0.65. Okay, so the mean is the 0.65, and the population standard deviation is 0.007. Okay, what proportion of population have a protein requirement?
So we need to solve for X, right?
It's less than 0.65. I would say, let's see, let me get a page. So you have 0.6.
What is the 0.6 representing?
The 0.6 is the sample or no. Just what proportion of population have protein requirements? So you're trying to evaluate has less than 0.6 grams of protein. It's asking you for a proportion. And the proportion is calculated as the z-score. So basically what it's asking, in my understanding, is the z-score. The 0.6 we subtracted by the 0.065 and divided by the mean.
Oh, the 0.07?
Yes.
Okay.
But we will get a negative number. I don't know if that number has to be positive or negative. Let me see.
Well, because, I mean, it shows here that you can have a negative z-score.
Okay.
Did you get negative 0.714?
I'm working on it. Negative 0.833.
When you did 0.6 minus 0.65 divided by 0.07?
Oh, 0.07, I put 0.06. There you go. So I got negative 0.7143.
Okay. So I would say that our z-score is 0.714.
Negative or positive?
I am not sure.
Hold on, let me read an example here. This shows the number of standard deviations individual is above or below the mean. So it's below the mean then, that's why it's negative. Right? Is the 0 up by the mean? Yes, the 0 is by the mean in the graph. So because it says the mean is higher than the actual what it's asking, I think
Okay.
it should be correct to answer with
Okay.
a negative. I don't know if that makes sense to you.
So the next question though, I just don't understand how we find it. What proportion of the population have a protein requirement that is more than 0.60?
What proportion of the population have a protein requirement that is more than 0.60? Instead of, well, it would be the opposite, wouldn't it? All the people that are above, so you subtract the point.
So would it be 0.76?
Wait a second, what proportion of population have a protein requirement that is more than 0.6? More than 0.6. I'm a little confused here. Hold on, let me check the reading. So of course it's gonna be above the mean because, oh well, the mean is 0.65. So it's asking from the ones that are from 0.6 and up, so in between the mean. It's asking us for the area in between 0.6. I know graphically what it means, I just don't know how to get it in the formula. You guys have any ideas? What percentage is 0.6 out of 60.65? Is that 90 something? 98 or 95?
Why would it be 98 or 95?
Oh, just a random guess, trying to. It's 92.
How are you? I guess I'm not sure how you're getting that answer though.
No. That's not the answer for the
Oh,
question.
okay.
I'm just. The 68% is that. So because the mean is so high, probably it is skewed to the left. I mean, to the right. No, to the left.
Whitney, do you know what's going on?
I have no idea.
I could draw it and see if it makes sense. Let me see. So we have this would be, what's the mean? 0.65, right?
Yeah. So is this where it's, I mean, but if you haven't read the chapter, I guess you don't know where we would be. So in the chapter, it talks about where you have to take like the heights. Well, so in the chapter, it talks about.
Yeah,
like,
I was just reading that.
and you take the heights minus the standard deviation and divide it by the standard deviation. Is that what this is asking for? I think so.
Because we will give both numbers the same if we do that.
No. You shouldn't. I guess so, because they're both they're both 0.5 away from it, huh? I have no idea. I think I'm just gonna submit these answers and then read through the chapter again and try to figure it out.
Yeah.
Okay, converting a Z-score to probability, 3.2. Using this app, we can
The
calculate
problem is we
proportions of
don't have
probability.
the Z-score yet, though.
Yeah, but the Z-score is easy to calculate. It's 0.714. That's what we calculated in the one above. Okay, type the Z-score on the boxes on the limit from the axis of the graph. Click on the areas under the curve until your areas are left in the Z-score in shaded blue. The total shaded area under the normal distribution, blah, 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 blah. Here above the graph, this is the proportion of young Ghanaian women who are shorter than Surwa. Okay, I think this is the example given for the heights, if you read, if you read 3.2, 3.21, that gives you the example that we need. And probably we'll have to use the applet thing.
We'll have to use the
calculate
what?
The applet,
Yeah.
probability applet.
So we're doing 0.65 minus 0.60 divided by 0.07, right?
Yes.
So we'll go back to the first one and try it again. So question 13.
Yeah.
Okay. 0.65 minus 0.60 divided by 0.07. I got 0.714.
Okay, so that's our Z-score, and now in the applet, you type it under there.
Uh-huh. Got that.
Okay, and now what's the question asking?
What proportion of the population have a protein requirement that is less than 0.60?
So that would be the area on the left side, from the Z-score until 0, until the negative or whatever.
So 0.2.
376. And the other one is asking the opposite. So what proportion of populations have a protein requirement that is more than the 0.60? So it would be higher on the other side. It would be the same one, but positive, according to this.
Wait, no, I don't know. I guess, but I don't feel like that's right.
Hold on. Let's read that a little bit. So a proportion of the young Ghanaian women reach height that is below 169 centimeters. To answer this question, we need to find the area under a normal density curve. For example, the probability that is to the left of the Z-score, 2.041. To find the area under the normal curve corresponding to a Z-score, we do the following. Type the Z-score into one of the boxes along the horizontal axis. Click on the areas under the curve until only the areas left to the Z-score are shaded blue.
Yes. Are we still on number 13?
Yeah.
Excuse me. So I just asked my husband, so I don't know. We'll see. We'll decide if it's right. This is what he said. You take the 0.65 and you subtract the standard deviation, which is 0.07, right?
Mm-hmm.
And then it gives you 0.58, which is 0.02 less than the 0.60. So negative 0.02. Does that make sense? Because that's how many, what is it? How many
That's how many people, proportion of the population falls outside of the standard deviation.
That makes sense. So negative 0.02.
2.
Yeah, I think that part is early in the chapter and we just skipped
But
it.
that's not a proportion, though. It can be a negative proportion, can it?
Well, we were already putting in a negative proportion.
Yeah. But I'm just following up the reading, and proportioning is asking us to calculate areas under the curve. That would be, I don't know.
Well, you're asking what falls outside of the standard deviation that's still within the bell curve. So that 0.02 is the proportion of the population that still falls within the bell curve based on your standard deviation that's below this 0.60. So when you talk about proportion, you've got that bell curve, right?
Mm-hmm.
Yeah.
And the center point, or what's based on this, is the 0.65.
Right.
That's the center of your bell curve. So then when you get to the outside layer of your bell curve, the 0.60, then the remaining portion of that bell curve, everything that falls underneath it, is what is your basically proportion of the population that has a requirement that's less than 0.60. So if you're following the bell curve, then what's the outliers, or that 0.02, and technically you could argue the 0.04 because it's also the people above that, but it's asking specifically the requirement for less than 0.60. So there's only 0.02 that is remaining, and then everything outside of that is outside of the standard deviation bell curve, and so it's not included in the population. If that makes sense.
Yeah, but the 0.6 is not a proportion. It's just an indicator. It's just a data. What is required for the population? It's a gram of protein. It's not a proportion. It's not a percentage.
Exactly, but the 0.65 is
The
an
mean.
indicator as well that determines the start of, well, the center of the bell curve.
Yeah.
So the 0.07 is your standard deviation to either side of that 0.65. So you either go below the 0.65 by 0.07 or above the 0.65 by 0.07 to find the outside liers of your bell curve.
Yeah,
So
I understand
wanting to
that.
find the proportion of the population that's less than 0.60, because on your bell curve, the indicators are all going along the bottom from the 0.60, the 0.65 all the way down to 0.58 or all the way up to 0.72. So the proportion, which is still, it's asking that deviation, is still that. Now, if you wanted to find the percentage of that 0.02 based on the standard deviation, then you could go ahead and do that. So you have basically 14% give, so a 0.02 is the percentage. So whatever 0.02 is of 14 is your percentage if you want to do it in a percentage. But
Okay.
your proportion, the amount below the standard, below the 0.65, below the 0.60 is the difference in your deviation.
Okay.
I think maybe we should all reread the chapter and just meet Thursday because I am confused. And I don't think we're getting the right answers either way that we do it, but I mean,
Well, I don't know. What he said, it makes sense to me. But I'm just reading, and the reading tells me to do something else. So, yeah, maybe we can just double check and read it. Right now I have to go because I have to go to the meeting that I have for my job.
okay.
Okay.
And if you guys want to submit it, it's fine. But if you want to go over it again on Thursday, I guess we can. I don't have anything against that.
Okay, we can I'll submit both these links, and if we want to work on it throughout the week and we think we got it figured out, we don't have to meet again Thursday, but that's up to you guys.
Okay. That sounds
Yeah.
good.
Okay,
All right.
All right.
sounds
Thanks.
good. Thanks.
Bye.
Thank you. All right. Bye.